These are a set of drawings for a project known as Madeira Tampa. It's quite a large project, and there's a tremendous amount of information in the plans. Plans themselves are quite large, but it provides us with a good example of what a very complete set of construction plans look like. There are similar features throughout the drawings, and the way that each sheet is organized is important to recognize. Each page in the architectural set of drawings is known as a sheet. So this is one sheet that we're looking at here. Draw your attention to the sidebar. In the side, we have a certain set of information that's going to appear throughout all of the drawing sheets. Okay, we have the architect's information, the structural engineer's information, a mechanical, electrical, and plumbing engineer's information, and then we have the project's name and project information, the owner's information, and then we have a schedule of different, it looks like, drawings. Okay, now we have a triangle with a hashtag in it. That's a symbol. Okay, architectural drawings are full of symbols. The symbol indicates, this particular triangle with the hashtag indicates a revision number. And so you can see these are the design document titles with the date that they were released. And then when there are revisions, there will be a number corresponding to, so there could be a revision 1, revision 2. In this case, the drawings here on 10/14/19 were revised for the 5th time. It's something that's worth referencing a lot of times if there's confusion. Do you have the most current set of drawings? That would be indicated, on each sheet, a revision history. Okay, and then there can be a seal from the architect or engineer where they'll make an impression on the page. A lot of times that set gets submitted to the building department. And then you have a sheet title. So this sheet is called the cover sheet. And then you have a sheet label. This sheet is labeled G0.00. So G0.00, it's the cover sheet. It contains the title, the name of the project. They have a rendering of what the building will look like. And then they have information here at the bottom, the project team. As you can see, a civil engineer, they tie in utilities and site work, the grading, landscape architect for the building that can be separate from common areas, public spaces, roads. A structural engineer designs the structural elements that support the building, mechanical, electrical, and plumbing, and then interior design. So these are different professionals, different companies that are collaborating together on this particular project. And you can see in the rendering it's quite detailed. The architects used a very sophisticated software program to create what essentially it looks like a picture of a building that they're designing. In reading a set of architectural plans, the first thing that you want to do is find the table of contents. That's going to tell us where the information that we're seeking is actually going to be found. So on the next page, they call it the list of drawings. Okay, that's going to be essentially a table of contents. And what's interesting about this project, it's quite large. You see general, civil, landscape building, structural, architecture, plumbing. So these are different drawing sets that were developed by these different companies. And over here in the drawing revision history that's on every sheet, you can see the dates that these different things would have been released. Now, for our purposes, we're primarily only interested in the architectural drawings. So if we have a closer look, we can see they have provided a sheet A1.01. That's abbreviations, keynotes, general notes, legend, and symbols. So architectural drawings are two-dimensional representations of three-dimensional things. As you know, it is difficult to represent a 3D object in a two-dimensional form on a paper drawing. For that reason, architects commonly use symbols to convey additional meaning. This is the table of content. Down here in the lower right, the architects labeled it the list of drawings. It's essentially the same thing. On this particular list of drawings, we have the different sets of drawings, so general, civil, landscape, landscape building, structural, architecture, plumbing, etc. All of the different drawing sets that were developed by different design specialists are combined in the building plan that is released for construction. In this case, it's a very large project, and so it's much more organized than most. But you'll notice that we have the same features as the cover page, where we have our sidebar. We have a sheet label. This is G0.01. We have the project information, the architect, structural engineer, and then we have our list of drawings. Now, we're interested in particular in the architectural drawings because that's what primarily controls the work that our company does. So we have here a list of all of the sheets that have been developed and the sheet names. So A1.01, abbreviations, keynotes, general notes, legend, and symbols. That's an important sheet because it's going to tell us how the architect has organized certain information within the drawings. Two-dimensional representations of three-dimensional things often need a little bit of help in terms of symbols. If we continue looking through the list, we see that there are different code diagrams. We have a door schedule, typical details of what the door looks like, finish schedules that's going to tell us what color certain things are. We have column locations, edge of slab plans. Then we're interested in first floor key plan, first floor plan A. This project is so large that they divided the floor plan into different smaller drawings so they could include more details. So you have floor plans, elevations, building sections, wall sections, section details, plan details, glazing types, what we would mostly think of as a window schedule. And we have a number of other different drawings as well. They're all listed out here. The abbreviations, keynotes, general notes, legend, and symbol sheet A1.01. You can see a legend here which shows us some different patterns. There are going to be some depictions of materials used in the construction of the building, and when those materials are indicated, they're going to be drawn or filled in with these types of different hatchings. Hatchings can vary from one drawing set to the next. A lot of times architectural firms will use consistent representations of these materials throughout all the plans that they create. We also have a table of symbols. This is an elevation, a building elevation tag. So we have an elevation number on the top, and then we have a sheet number on the bottom, and then we have a black arrow that's going to be pointing some direction. But these tags correspond with the elevations that are going to be used. We also have a glazing tag. It looks like a diamond shape with a glazing type indicated in the middle of it. We're going to see these different symbols used throughout the set of drawings. And it's nice that this set of drawings includes this information. A well-developed set of building plans ordinarily will include that information. And then we have general keynotes, master keynotes, abbreviations, so they might, use different abbreviations throughout the set of drawings. Sometimes when you're reading something and it doesn't make sense, it would be helpful to refer to the abbreviations page to comprehend exactly what is the intended meaning of what you're looking at. This is the first floor plan, and this project is quite large. So you can see down here in the bottom right, we have first floor key plan is the sheet label, and then this is the footprint of the building. Okay, it's all shown in gray, and that corresponds with what we see depicted on this page. Okay, there are dimensions throughout. This is how we are able to locate certain things and lay out the building. You can see that the overall building length is almost 400 feet, and then we have 25 feet 3 inches between these grid lines. If you look at the key plan here, we have some lines coming through it. That's corresponding to what they have labeled here as a match line. Match lines divide the building into different sections so that they could show us on each of the sections on its own drawing sheet. This building is just too large to include all of the information that's necessary to build it on one sheet. We also have some different tags. This is an elevation tag. It tells us that drawing number 1 on sheet A 4.03 is going to contain a drawing as if you were standing in this location and looking in the direction of the black arrow. We're going to have a look at what that part of the building is. This is a section marker, and it tells us that drawing number 2 on sheet A 3.10 is going to give us a section of the building that's looking in this direction as if what's to the left of it doesn't exist. So we're going to see right through the walls, and that's going to give us a better handle on how is this actually constructed. Here's another elevation marker. Tells us 1A 3.01. As if we're standing here and looking at the building, we're going to see what that elevation looks like. This is A 3.01. This is drawing number 1, and this is what the building is going to look like at this location. See, we have some entrance. This is on an angle. There's a parking garage. There's some storefronts. This is open, and then we have another set of something here. We go back to the floor plan, we can see, okay, yep, we've got our storefront on an angle, an entrance to a parking garage, a separation between buildings. If we go back here, yep, you can see there's the separation between buildings, but if you look up above the first floor, there's still a full solid building there. On the first floor plan, we're only looking at a slice through the first floor. So that's going to be, see this hashed line here? It's going to be something around this level going down not going up. There's nothing depicted here on the first floor plan. So our match line is not going to be into any of that material. Then we come down, we see the parking entrance in this other angled storefront that shows on our first floor plan. The floor plans and elevations are important to look at together because they show the intended construction. This sheet contains elevation drawings. An elevation drawing is a two-dimensional perspective drawing, which is if you're standing in space and looking in a direction, you see the elevation drawings. These elevation drawings are referenced in relation to a floor plan. So if we have a look at the floor plan, we see the whole footprint of the building here, and then if we'll zoom in so that we can read our elevation label, we see that drawing number 1 on A301 is going to be an elevation as if we're standing and looking at this side of the building. We have an angled storefront, looks like an angle, and then an entrance to a parking garage, some lower building, a separation between the two buildings, another building. In this particular building, we have a lot of glass. Now, the symbols that show us what is glass and what is not glass, that's on another sheet, but if we take a look at the building elevation, we see the sheets divided into different drawings. Okay, and all of these drawings, they're all going to be labeled. This is drawing number 2. This is drawing number 1 on sheet A3.00. That corresponds with 1 on A3.01. So let's see, we're looking at the wrong thing. Okay, here's A3.01. And we found drawing number 1. And here we have what looks like an angled storefront, entrance to the parking garage, a separation between buildings. That's going to correspond with what we see on the floor plan. Little angle, entrance to the parking garage, separation between buildings. Here we have the elevation of the building as if we're standing here and looking at it. Looking at the elevations and the floor plans together is essential when it comes to building up this three-dimensional perspective of what this building will be from two-dimensional representations of that building. Now, if we take a closer look at this, okay, we have these diamond-shaped symbols with labels in them, CO8, that's going to be CO9. These are going to be tags that identify a type of window. Okay, there is a separate schedule of glazing types, they call it, a separate window schedule that's going to give us more detail on what these are and what they look like. Now, you can also see there some of these sections are circled in this dot line box, and we have a note here, okay, 1A413. That's going to give us a closer up representation of just this section of the plan. So let's take a look at that. An enlarged elevation. Okay, so we have these three. So this is A413. It's difficult to read that. Okay, that's door, fixed, door, door, fixed, door. We have our tag 1A413. Here we have our sheet. We're on A413, and we have our drawing number 1. So what they're showing us is some additional details that just didn't fit on the other page. Okay, if we zoom in here, they're saying there's a metal railing. They're saying there's a metal panel system, PNL-02. So we can reference PNL-02 elsewhere in the plan. It's going to identify what that is, probably the particular finish or type of material. And then we also see these corresponding grid lines. That's going to correspond to the floor plan. Okay, on this drawing we have some section markers. In particular, we have 2A413, and that's a line. You can see this line is going through the drawing, okay, and it has a little symbol at the end to indicate that it's closing this section of points. The line faces to the right, so if we find drawing number 2 on A413, we're going to see a drawing as if the wall was cut through and we're looking this direction. So this is A413. Drawing number 2 is right here. So you can see it looks like there's a door, and here's the construction of the wall. Looks like it cuts off just above the second floor. That's kind of the same thing. This line goes through the door. Yep, and then there's glass above it, and then glass above it, and then a louver, and then a sign panel, and then some kind of a stone veneer, STO2. So if we have a look here, we see there's a door that meets some concrete, and they're telling us for more information on how this detail and all these materials meet each other, we should look at drawing number 1 on A518, and that's going to give us more information. That'll be a detailed drawing of how those materials meet. So we have our door, glass above it, glass above that, and then a louver. And here we have another drawing number 2 on A518, and this area inside this box is what we're going to see in that drawing, and it's going to be blown up to a larger scale so that we can figure out how all of these materials are supposed to meet each other. And then we have the stone STO2 above the sign band. Our elevation drawings are linked to the floor plans with these elevation callout symbols. They tell us the drawing number in the sheet. When we refer to the drawing number in the sheet, we can see the elevation, and then sometimes, not always, but sometimes, in this case, the building is very large and it's not possible to include all of the necessary information in this one drawing, and so the architects provided a detailed elevation drawing number 1 on sheet A413, and we see that drawing here. It's blown up quite a bit. The different materials here are labeled, and this drawing includes some section, wall section markers, so we can look through the various wall section markers for A13, similar to A413 that we looked at. And then these sections are going to have callouts for greater detail, which we can zoom in on. So we'll take a look at A518 number 1. Okay, this is A518. So you can see here at the threshold, what they're telling us, the architect is telling us that the threshold is going to extend just beyond this concrete curb, and it looks like it's going to cover up this material 7H1. We can see 7H1 is cork joint filler. CJF is the abbreviation for that. Now it's also interesting, this is a section, okay, so it's like a microscopic slice through of the building here. Now you can see this is filled in, okay, you have a box and then this kind of aggregated whatchamacallit stuff. If you recall, we looked at the legend for the project, and the legend showed us how they were going to represent different types of materials. And you could see concrete, okay, it's represented in this form. And now if we go back into our drawing, it looks like precast concrete has a little bit greater density. Yeah, so in any case, it's concrete in here. Now they have these kind of weird aggregate material. We can see maybe that's indicated here to be some other thing. Yeah, so it looks like they forgot to include whatever material that is in their legend, but suffice it to say, it's some other material. You can see how different materials are represented with these different types of hatching, and they can be called out, with these keynote labels. We also have a kind of a dashed line, 7A2, in the keynotes that calls out a waterproof membrane. So what we're looking at is a slice through this part of the building. It corresponds with essentially this line right here, and it doesn't include very much. It might be like a 1 inch to the right only, just those points compacted into a two-dimensional microscope slide, if you will. But by looking at this image and understanding that it's going to carry through horizontally where the door is, we can begin to build up a three-dimensional model in our brains as to what it is that the architect is trying to represent to us in this two-dimensional drawing form. So we're looking straight at it and then 90 degrees to it, as if we're standing in the same plane as the wall and looking that direction. We can start to see the different pieces of the building and know how they go. And this is important because in order for us to install the glazing system in the correct place, we could see what they are showing here. They want the threshold to cover up the joint, but they don't really have good dimensions. They call the concrete 12 inches thick at the top of this detail, but here it says refer to structural. So the architect, this is pretty common, the architect designs the functional elements of the building, and then a structural engineer will review that and see. The structural engineer might say, well, you're going to have 14-inch thick concrete. The architect is just making a note, see structural for that reason. And then if you look at the top of the window, detail number 2, if we just go back to this one, drawing 2, that's this. And here we have 2 on A518, so that's going to show us the top of this window. This is 2 on A518. A lot more detail and dimensions in here. Okay, so we see that there will be some large piece of steel, 5A1. It's going to tell us what that is. Our storefront frame, it's going to be 9 inches from the steel to the inside plane of the storefront being 5 inches depth, and that puts the exterior face of the storefront approximately here, and the design calls for that this canopy member. Maybe this canopy member is not even installed at the time that the storefront gets installed. The canopy member is supposed to be 8 inches beyond the exterior plane of the storefront. So when we look at these details, we can see how are things supposed to be placed relative to each other. Okay, no architectural drawing review session would be complete without exploring the doors and door schedules. If we zoom in on this part of the plan, we can see the door label. Okay, if you refer back to our legend page, we can see that we have door tags appearing in this form where we'll have a door mark and then a door panel type. Okay, the architect calls that a door tag. So we have F101, panel type is B2. Now if we look at the door schedule, mark F101, okay, and that corresponds with F101, okay, a width, a height. This is the door frame opening size. The actual door leaf is going to be a little bit smaller than that most of the time to fit into this opening. The door panel, the material type is aluminum and glass. These are abbreviations. The door panel type is B2. Material aluminum for the frame material, it's aluminum. The frame head detail is number 5, jam detail, sill detail. It's not smoke rated. The hardware set is 107, and the lock set is LS. Remarks, it says main lobby C note 1. So let's see if we can find note 1. General notes: requires electric power for fire alarm or security. Okay. Materials and finishes, so aluminum and glass, ALGL. Hardware legend, lock set, passage set, exit device. Notes, see also notes H and I, sheet A130. Okay. So basically all of the doors on the project, on the floor plan, are going to be associated with some type of a tag or mark, and that mark is going to tell us, you know, how to find it in this table, and this table is going to tell us details that are important for the door. Its size, the frame type, the frame, any ratings, could have fire ratings, and then a corresponding hardware set and lock types. So this door is door panel type B2. If we go to the previous sheet, we can see they have a bunch of different panel types illustrated, and if we take a look here, this is roughly what they're saying that this pair of doors should look like, type B2. You may recall that the frame had various details, type 5, you know, all this. Okay, our frame head type 5, jam type 5, sill type 20. That's going to correspond with these details. So here's 5, so jam and head. We want something that looks like that. And then if we can find sill type 20. Okay, yep, so that door has this condition. It looks like a saddle threshold, regular old saddle threshold, and a note that says C threshold requirements. So our threshold requirements, it's going to tell us maximum height dimensions. This has to do with Florida Building Code accessibility requires that there not be obstacles to people coming and going. You don't want to create trip hazards. You also don't want to create barriers where wheelchairs are not able to pass. What we haven't seen in here is the hardware set. Recall here they specify hardware set 107. Sometimes building plans will include, hardware sets. They'll be listed out on the door schedule. In this case, you look at the number of doors and different hardware sets, it's way too many to list. And so that information is going to be provided to us in the specifications for the project. And the specifications are just written out what they want, okay? And they'll do this, here they have a section for door hardware. So this is going to talk all about what are the submittal requirements, what do we have to show them, packing, marking, delivering, how do they want them keyed, what special requirements do they have, which products are acceptable, so they want only from these manufacturers for these different types of things. Here are the exit devices. They say you could use these different ones, but only those. If you want to use something outside of that, you're supposed to get special permission from them to do that, and you continue on through this list. It tells you overhead concealed closers, what's acceptable, floor closer types, door pulls, every different type of hardware that could be used on this project. They are telling us what it is that they want, and if not one particular thing, then what are the set of things that would be acceptable to them. Finally, in section 3.5, we get to the hardware sets. Now, you see all these sets are numbered, and we got 107 here. If we go back to our pair of doors that we were looking at, we could see that it requires hardware set number 107. So let's take a look and see what kind of hardware they describe for that door. So they want 2 sets of floor closers, center hung, single acting, heavy duty, with recessed dress plates, extended spindles, less exposed alignment screws. Okay, so they don't want to see exposed alignment screws, and no hold open function in that closer. Okay, so they want a floor closer for each of the doors. They want 4 pull handles, so that means a pull handle on both sides of each door. They want 2 electromagnetic locks, so a mag lock for each door. 1 set of gaskets, that's pretty normal. Generally all doors are going to have some gaskets to cut down on the air infiltration. They want a threshold, custom full saddle type to coordinate with the floor closers as required. So that's essentially the architect saying, I'm not really sure how you're going to make all this hardware work, but just do a good job. They want 2 drip caps. And a note, coordinate with the owner for security and access control, which means they want electromagnetic locks, but they understand that there has to be coordination between some different vendors to make this happen properly. Special note about specifications, whatever it says in the specifications will supersede whatever it says in the plans. Okay, generally the specifications are the most specific thing that the owner or architect provides us in terms of the design documents. So this specification is regarded to be the most important, and if this says something different than what it says on any of the plan sheets, then we would disregard what it says on the plan sheets and rely on what it says within the specifications. And if you're in doubt about that, then you could request that the customer clarifies it for us. No discussion of reading architectural drawings would be complete without mentioning the window schedule. Not every project is going to have a window schedule, but when the project is big and complicated enough, you're likely to find a window schedule. When it's a simpler project, a lot of times the door schedule and window schedule can be combined onto the same drawing sheet. But in this case, we have an elevation drawing. The elevation drawing shows us windows, and our windows are labeled with these tags that correspond to a window schedule. The window schedule is going to show us more detail about these items. So, for example, we have this storefront opening labeled C8. This is labeled C3, C2, C1. So let's try and find C3 because we're showing it's at an angle here. It doesn't really make sense. It's not dimensioned. If we take a look at the window schedule, we see all of these different windows. So this is C19. They're all dimensioned. We can kind of go through these pages, and I think we have here, okay, C26, C25. Okay, here's C3, C2, C1. That corresponds with the elevation that we see here. Okay, and we're seeing just up above this a little bit, we see that we're being shown there's an angle between C3 and C2. Looks like 137.5 degree angle. So there are some columns in the building that are around these windows. And then the whole thing is dimensioned. So we have the height, we have the spacing between the different sections. That information tells us essentially how the window should be made or constructed. It doesn't tell us, it's important to look at this too, it's the intended design, right? It doesn't tell us, you see how this window, the horizontals appear to line up with something here, like that's on the same level. This might be an expansion joint in stucco or something like that, but it's important not only to look at the window schedule and where do they say that these horizontal elements are going to be placed within our frames. It's important to keep in mind that we're building a building with other trades, and it can be possible there could be a band of stucco that's supposed to line up with the horizontal. The contractor that installs that could potentially misalign it by a half an inch or 1 inch, and then if we just fabricate a window to what's on the window schedule, these dimensions, when we put it in the opening, it's possible that it doesn't line up. Another possibility is that, you can see in our drawing the horizontal elements of these 3 frames line up. Looks like it also is supposed to line up with this. It's possible that when these openings are made, there could be a slope from this side to this side. It could be an inch different in terms of level. So it may be important to measure these 3 openings relative to each other, not just the opening, but the relative height difference in the floor at this opening, and this opening. If the floor slopes an inch and we only measure each opening and make the frame just for that, then it's possible that the horizontal elements don't align with one another. Same thing is true, we're going to be providing a column of windows here. Okay, it's entirely possible that this opening is constructed 2 inches to the left, and this is constructed 2 inches to the right, and then when you look at this building, these windows are going to be crooked as you go up. So before we measure these individual openings, it's important to take a look at the elevation and ask ourselves, do they align, do the openings align with each other as they do in the design? The other interesting property of the window schedules, it gives us details on the construction of a specific window type, but it doesn't give us the quantity of each different window. It's possible that there could be multiple types of, each. So type S58, there could be 50 of these on the job. There's only going to be one representation of this type on the window schedule. So how do you figure out what the correct quantity is? Well, counting off the window types from the elevation. So you have SO2, SO2, that's 2, and cross-referencing with the floor plans. Not all windows are going to show up in the elevation drawings. It's important to cross-reference the elevations with the floor plan to make sure that we've accounted for the total quantity that will be required.